In this video, we're going to be talking about combinations. And combinations would be collections of people or objects without regard to order. So for this first example, if we're talking about the numbers 1, 2, and 3. Now, if I was referring to this as a permutation, where the order does matter, and I'm going to use all three numbers, then I could end up with not just 1, 2, 3, but I could also have 1, 3, 2, and that would be different. And I could have 2, 3, 1. I could also have 2, 1, 3. Or I could have 3, 1, 2, or 3, 2, 1. And those would all be different. But in a combination, we're saying the numbers 1, 2, and 3, regardless of the order, it's still those same three numbers, and the order doesn't make a difference. Maybe a better example would be if we were talking about a basketball coach with a team of 12 players and choosing the 5 starters. And so how many different ways can the starters be chosen from this group? So we've talked about it as if there's positions. I have 5 positions to fill, and we have 12 players to choose from in this first spot, then 11, 10, 9, and 8 different players to choose for that last spot. This is the same way we did the permutations. We're going to multiply across here to find out what our total would be. That is 95,040. But that counts everything just like we showed with the permutation, where we're saying that all of these different combinations or different pieces are the same. To take away the repeats, what we do is we'll take each of those positions and multiply across there. We have the 5 spots, so we're going 5 factorial across the bottom there. And so that is the piece that we're going to be dividing by. And so it turns out that there would be a total of 792 different combinations in that scenario. What a combination is doing is we're talking about all the different possible outcomes here, and when we eliminate the n minus r factorial on the bottom, that's taking away the overlap piece. So for example, in that example we just had, we were talking about the basketball players. We had the 12, 11, 10, 9, 8 on the top, and we had 5 times 4 times 3 times 2 times 1 on the bottom. Well, remember what we're saying here is that our n value is how many we have to choose from. In this case, there's 12 players. And our r value is how many positions we actually have. There were 5 starters. So when we do the n factorial, that is 12 factorial. Now remember, that goes from 12 all the way down to 1. And then on the bottom we have r factorial. And then we have the n minus r factorial. So in this case, n minus r, that's 12 minus 5, that is 7 factorial. That piece is eliminating, so here we had from 7 on down to 1. And if we think about the 7 factorial here, that's canceling all those out because we only had 5 positions. And then this piece, the 5 factorial, takes care of all of the extras. Now, what we're saying then is that rather than counting these as 6 different ones, we're saying there's just one. And again, our calculator has a function to do this if we go to math and over to probability. So again, we have permutations, here is combinations. So if we're looking at the 3 options and we're doing a permutation, and we're going to use all 3, just like we talked about here. 3 numbers, going to use all 3 of them. There were 6 different options, just like we showed. But if we do 3 numbers to choose from as a combination, and we're going to use all 3 of them, then that's showing us it doesn't matter what the order is, we're going to choose those same 3 numbers. So looking at another example, there are 8 juniors and 12 seniors on the student council. We're going to send 4 representatives to the state conference. So first we're going to look at, well, how many different ways are there to select a group of 4 to attend the conference? So again, if we map all this out, we have a total of 20 to choose from. So 4 positions, 20 to choose from for the first one. Then we have 19 people, then 18, then 17. Now the order doesn't matter. So that's where we're going to eliminate all the different permutations, all the different ways they're grouped by taking the 4 times 3 times 2 times 1 and dividing there. So we end up 116,280 ways to arrange that, but there's 24 different groups that are being repeated there. So it turns out that out of those 20 students, to select a group of 4, there would be 4,845 different groups that we could choose. Now, if we were to say we're going to send 2 juniors and 2 seniors, now what we're looking at there is, if I look at just the juniors, now I have 8 to choose from, and I have 2 spots. So I'm going to have 8 and 7. Now again, there's 2 spots to choose from. So 56 divided by 2, there's 28 different pairs of juniors that we could send. If we look at the seniors, now we have 12 to choose from. So 12 and 11 for those positions. Again, there's 2 spots, so 2 times 1. So that would end up giving us 66 different possibilities there. Now, counting principle wise, if I have 28 options there and 66 there, when we multiply those together, that would give us our total number of different groupings possible with that scenario. So that'd be 1,848 different combinations.